or something. I'm unable to kind of know. I don't get a notification when you send.
Hey everyone, good day. Welcome to another installment of the Build with Celo hackathon. So tonight will be the second part of the build and exchange on Celo using Solidity, Celo Composer, and Fiat-connect. So with us today with Oluwafemi Alofe and Habib Sentongo, and Femi will be rounding up his session from yesterday, and Habib will be kicking off, building the back end with Node.js. So with that being said, I'll be passing this off to Femi to continue from where he stopped yesterday.
Hi everyone. I'm glad you are able to join us today. And if you did not join us, if you did not get a chance to join us yesterday on yesterday's session where we started writing our smart contracts for our exchange, please go back to YouTube after this session and look at like the part one of this workshop. So I want to conclude the parts of our smart contracts. Yesterday, we were able to go from step 1 to step 5. From step 1, we were able to create our exchange factory contracts, our wallet implementation, our wallet proxy. We're able to add all of the necessary functions to our smart contracts. And we got to where we were supposed to write our test, and then we ran out of time. So briefly, in about 10 minutes, I'm going to write a test for our smart contract. So for those that did not follow up until this point, you can just switch your branch to version 004. That's where the test has not been written. And for those that have started, you can switch to between 004 and 005. So that's where I'll start from. But I'll continue with the code base that we have from yesterday. So I'll switch to our repo now. All right. So the first test that we want to write, that we're trying to do yesterday for our last one, is to check that the implementation contract, which is our wallet implementation contract, is what we expect it to be, right? And I explained that right inside here, inside our before, right here, this is going to run before any of our tests. We are trying to do like a setup, right? In adults, you can use fixtures to do this, but I'm not using fixtures here. I just prefer to do it this way. And what we are doing here is getting our signer 1, signer 2. We are deploying our wallet implementation contract. We have to deploy one implementation contract. And then we're deploying our exchange factory. And while doing that, we call initialize on our exchange factory. And remember, our upgradable smart contracts using open sampling. So the constructor, it doesn't have a constructor, so we called initialize. And in initialize, what we did was pass the wallet address of the implementation, which we use subsequently for getting code for our smart contracts proxy. Another thing, again, I think I added again afterwards, I would say is inside our wallet proxy, there is a check inside our wallet proxy that ensures that this wallet can only be called by the owner of our wallet, of our exchange factory, of our exchange factory smart contracts. And let me explain quickly what that means. If you look at it this way, our exchange factory is the factory that deploys all of our wallets, right? For every customer that signs up on our exchange, it deploys a new smart contract. And the smart contract is wallet proxy, all right? And the only person that can call our exchange factory, if I come here to check this out, again, we have to rename this. This is supposed to be. Now, the only person that can call our exchange factory when it comes to deploying our wallets is the owner of this smart contract, which is going to be a private key, right? So in that case, it means that for anybody to be able to interface with any of our wallets of the exchange, it has to be the private key that is doing that must be or has to be the owner of our factory. All right. So that being said, let's go back to our first test. So our first test is Yeah, we already deployed
If
our
I
wallet
may,
implementation. Yes.
can you zoom in a little so our users can see what we're writing today?
Okay. How about this? Am I on the right Zoom?
Maybe one more. Well, I think you're good, sir. I think you're good.
I'm good, right?
Yeah.
Okay. Yeah, I think this is very bold now. Okay. All right. So our first test here is to check that this implementation matches with what we expect. So we already did it yesterday, so let's just run it. So we have npx add on tests exchange text.js. Let's see what our problem is. Before is not defined. No, run is not supposed to be there, so gbmp add tests. Yeah, that's why it can't get that. Yeah. So here we have like our test passing here because the implementation contract, we confirmed the implementation contract is exactly what it's supposed to be. So let's go to the list of what we want to do. So the next thing is we should deploy new wallet for new user. We should revert deploy new wallet for new user. So let's test that. Let's see, why should he revert? If we say okay, new wallet UID. So one way to confirm our revert is, let's try something. Require UID dot length greater than 0. Let's just do that. Basically, it's supposed to be greater than 30. It's supposed to be greater or equal to 30 actually. So let's do. We want to be that length. What it? Exchange factory invalid UID. Right. Okay. Let's try this now. So it should create new wallets. Now we can create a wallet from our factory. So we should do right here. We should say, okay, for it to create new wallet, we need to do this dot let's factory is where it is dot new wallet and UID. All right, to get UID, I tend to do it this way. UID generator.net. I mean, if you're writing the backend code, this will probably be the ID of your. This will probably be the ID of your user on your MongoDB, or you could literally use. There is a library. There is a UID library that you can use to generate UID that you can use. Whichever case still, you can do that. So let's do this and remove this. All right. UID, and then await, and would try to get the wallet, the address of that wallet. Again, this dot factory wallets. Remember this mapping that we have right here? The ABI automatically generates like an assessor for us. So this mapping we have right here, public wallet, so we can always get it here. It gives us the address. All right. When we create new wallets, all that happen here is it creates it right here and put it inside of here. We can get the returns true. That's all. So again, UID, and then that's our wallet. For now, let's just do console.log. Let's see if we actually gives us the smart contract, like the wallet address. So here, let's run this. That should not be what I run. Yes, that's it. And just to touch base again, because I know the code was not zoomed when I was showing for wallet proxy. Remember that there is a requirement here that I did just to check that, yeah, the exchange. Do you know if the exchange factory is the one that can call any of our wallets? So there you go. Let's see what it says here. Game exception, by the way, string, enable caller is not owner. Okay, yes. Let's see where caller is not owner, but caller is owner. So, yep. So now there are some things that we did not do yesterday that we were supposed to do. The owner for this smart contract was not initialized. And for us to do that, we are supposed to add all of these. We are supposed to call this enable.init. So to set our owner, that's where the prop is coming from. Enable.init, do this, and same thing here. Again, because upgradable smart contracts do not have constructors, we just have to call this ourselves. So again, possible inits. You can go through all of this in your spare time to see how all of this is defined and do some research more. But yeah, that's why. So yeah, again, let's compile. Now let's run our tests. Yep. Not an error. It is passing, but it's not logging what we want it to log because it's an await. So let's see. Yeah. All right. Yeah, await. Now we should get what we should get. All right, now here is it. Here is what we are getting, which is this is going to be like the address of our user, like a new user that was just created. This is the wallet that was created for this user. Now, what we have to test here now is that, all right, when we are creating these new wallets, we are emitting that UID and the wallet. So we need to confirm that it's emitting the right event. And in order to do that, let's go to add that documentation. Add as. We are going to be making use of this guy, Adat Chai Matcha. I mean, it's already there, it's already installed, but I just want to show you. Now with that, you would see that we could actually do this. We can say, oh, expect to be reverted, which we'll do soon, and expect, to emit this event with arguments. So let's do this. Let's say, okay, we'll expect it. We'll expect constant response. So we expect, right, this. So let's mistake there. To emit events, new wallet, right, with arguments. What are the argument do we have here? UUID and wallets. So let's see. And that's error response to emit. So let's see what's happening here. To emit token transfer. All right. Now the first argument here would be that is supposed to be token. That would be this dot. That's the contract. This dot x factory. Right. So we expect this factory contract to emit new wallets with argument this. So let's see. Let's run our test now and see how that works. All right. Yeah, it's passing. It's doing what we're expected to do. So now another test that we would run is that if we are trying to create a wallet, we are trying to should revert, it should revert on creating whatever. Trying to create a wallet with a UID in this case, less than 32, the length of 32. Now you need to understand this can be tricky a bit because now if you understand how string works, and how bytes are handled, you would know that it is assuming that one character is going to be it's going to be checking one character. It's going to be doing one character as 1 byte this way. All right. But if it's ASCII, but if it's not ASCII, means that there are some characters that it will reserve over 1 byte for like 2 bytes. It means that this can be tricky a bit. For example, this would work, but if you would add, instead of putting 2, if you put things like, let's see, what character, maybe this, or maybe any funny character that would take more than one. I would take more than 1 byte. Like one character will take more than one. It will reserve more than 1 byte for it. That means the length can begin to be funny. But I would expect that you would not have that kind of character anyway. But I just want to put the word out there. But if you have something less than 32, right, and you try to create a wallet, we expect it to revert. So let's see this. We expect it to be reverted with this error. So await expect token the transfer to be reverted. So let's see. Expect this to be reverted with, let me see that. Yeah, .2 .b reverted with, and then the error. So in this case, what's our revert error? SF invalid UID. Let's run our test again and see. Let's see. Reverted with this. Oh yeah. So I think we don't need this. Yeah. This should just simply
Femi,
be here.
could you zoom your screen again?
Oh, you're zoomed?
Yeah. Our followers are saying they can't see the words.
How about now?
I think that should do.
You should can you ask whosoever the person is to know if you know.
Yeah, I'm asking.
Yeah, I think this is good.
Okay, all right. So should revert on create wallets. Let's try that again. All right, I'll test the passing. All right, now that we've created our wallet here, let's start interacting with the wallet. And for that to happen, again, I like to do this. Instead of calling it wallet, I would do so I can access it from the nest, like my nest test. I'll just do these dots. Let me call it these dots. Customer. Yeah, because of course this wallet belongs to our customer, right? And I can just put this here. Our test should still be passing if I do that. This is customer. All right. Let's try to run this. Okay, now let's write a test to get the version of our wallet. Now we want to call this on our wallet now. We want to say, let's see. This. Now, when we deployed like that wallet, we say this is implementation. That means that we should be able to call things like version and it will return this for us. So let's say that I want us to write two more tests. One will be for version, and the second will just be to get, also 20 token balance or something. I'll just stop at this one so I don't take all day for everybody. So it should return wallet version as v11. So in this case, sync this. All right. Now, what we have to do is, while writing this test, we can't simply do get factory, it has your get factory wallet proxy, because remember, proxy smart contract is just a storage. The implementation is going to be this wallet. So we'd actually need this implementation to call that function from. All right. And then we'll now attach this newly created address to it. That's how it's going to work. All right. So let's go back to here, our features here. Now I would say this dot wallet implementation, which gives us this, would say actually wallets here, it sticks your wallet implementation dot attach. All right. We're attaching this dot customer here to it right here. And now we can call wallets dot version. So let's do console log and see. I see. So now you see that the version is returning is v1001. But here is what I want you to understand. If you come to wallet proxy, you would realize that I actually play some console log here just to see how this works. Now, the contract is calling actually is our wallet proxy, right? But using delegate call, it is copying this version from it, all right? Now, let's track how the call happened, right? When it calls wallet proxy, version function is not on wallet proxy, all right? Now, because the call, the transaction that we are making to this wallet proxy smart contract, which was deployed, which will be deployed for every wallet, contains a data, right? Remember yesterday I said if the call contains the data, it's going to fall back to this fallback function, which is like standard solidarity thing. But if it doesn't contain data such that maybe we are sending transaction, maybe we send Celo to this wallet, it's going to call receive. But because it contains data, it calls this fallback, and then here we have this fallback function here, and what it does is that's why I put this console.log. It does fallback code. As you can see, it says fallback code, right? And then it calls before fallback, which we're not doing anything inside of that. But if you want to make use of that, you can do. And then we have delegates, which would first call implementation. And then you see implementation code. Here you see implementation code. And then it returns here. It gets the implementation of our wallet, which is the address to this implementation contract. All right. And then it returns implementation to this guy, and our wallet proxy, which serves as the smart contract for all of our wallets, each of our wallets, for every of our customers, they have a new wallet proxy, delegates the call to this guy. So here is where the magic happens. Then it delegates the call. And remember, we are checking here that the only person that can call any of our wallets at all from now or in the future is our factory owner, which is like the person that deployed our factory smart contract, which is the private key. All right. And you will see here that's the case. It passes this check, and here it says delegate call, which is where this assembly code is being called, which is very common. You see, it's using delegate call and call the implementation, which has this version, and then it returns version v11. All right. So that's like, super interesting when it comes to proxy smart contracts. Now, let's just say start. No, it starts. Let's just expect. Let me just copy this. So we expect. Oh no. So we expect that our version, our wallet version will be equals v1.1.0. All right, everything works. I mean, we might want to remove all of these consider.log and everything, but I would not remove it just for the purpose of your learning. Now, I would be pushing this branch. This branch right now is called 001 solidity _ dry run 002. So you are able to follow up from there. Maybe you'd want to continue the code from there. But in actual sense, the completed code can be found on this branch.
Femi, all this is not visible. Please zoom in.
Okay. Sorry about that. How about now, please?
Better.
Okay, yeah. So as I was saying, you should check 001 solidity dry run 002 to move on from where I stop right now. But that's like an advice I want you to kind of follow. I don't want you to simply just come and look at the completed code, but for you to understand how everything works, the completed code is actually the completed code for the rest of the tests, right? Where you would see that we have the rest of the test that talks about these fixes will be fixed. That talks about everything that needs to be done, which is should be able to transfer tokens, to be able to do all of this stuff. You can check completed code for that here. So that being said, I would switch now to Abib to take you on how to build the back end of the smart contracts in order to interact with the smart contracts. Thank you guys. As I said, I would push this code right now. So status, it commits, add message, work in progress, writing tests, hit push. So, all right. Thank you guys. I'll hand over to Abib now to continue with you guys.
All right.
Okay, everyone. I'll be switching over to Habib to kick off building the backend with Node.js. So Habib,
All right.
take it away.
Thank you. All right. Thank you, Ernest, and thank you for that good presentation, Femi. And hello, everyone. So we are going to be kicking off our next part of building our exchange, which is talking about how the backend is going to be implemented and then how it works with all the other parts of the app and why it is even being done in that specific way. All right, so I'm going to just stop sharing this slide and share my whole screen so that I can show the different. All right, Ernest, could you please help me confirm that my ID is visible?
Yes, I will bring it up in a second.
All right. Okay, am I good to go?
Yes, you're live now.
All right, thank you. So hello everyone again. So as we saw in our first stage of the application, we took some time and developed all our smart contracts that will be needed to run this exchange app smoothly. And if you now get the gist of how our whole application is organized, we built it starting from Celo Composer. So Celo Composer comes with this kind of directory arrangement, and we have all our packages in the packages subfolder here, and everything that you have just seen that Femi worked on is in here in the hard hat package. And now I'm going to be touching another package, and so the app is made up of three parts. That is the smart contracts part, then the front end, which is built with React, and then the back end, which is built with Node Express. And that is what I'm going to concentrate on at the moment. So you will start a basic Node Express application as you start out to build Node. So you'll create an independent package here and install any dependencies that you might need for your Node application or for the Express server, and then create your entry point, which would be app.js. And this entry point is the file that will automatically be run first the moment you run your backend server or the Express server. So we are going to be using the MongoDB, that is Mongo database, and it's going to store all our user data. And then you might wonder that, well, since we are using blockchain, why are we not storing our data on the blockchain? So it's just a reminder that we don't store all and any sensitive data on blockchains. We only store key data that necessarily needs to be there and never needs to change. So then after you create your entry point, you will tell your app how it will run, and how does it know that you create an app.listen function here, and that tells the app on which IP address to run and on which port on that IP address. And then how does it know the URL and port? So you set that in your environment. So if, like, as you can see here, I have a .env. So this is the example that you'll follow in case you go and clone our report to run this on your local machine. So the backend will need these different environment variables. So one is the port to run on, and then the mode and so on. Then on the other hand, it will also need the DB credentials or the DB setup. That is where you're hosting your DB in case you're using an already hosted DB on Atlas, or then the port and anything else. And with all that data, then you can use it to create your DB connection string here. And then if you try it out, you would see that the application is well connected to the DB. So I'm not going to be going through each line of code here, because this session is actually not to learn Node Express, but to learn how to build on Celo. So I'm going to basically concentrate on explaining those parts of the backend server that like I'm going to mainly talk about how to connect this backend server to our smart contracts and why do it that way. That is going to be my concentration area for today's session. So I've already talked about creating the server and how to connect it to the database. And then, of course, you'll need to create some models. Specifically now, the backend is mainly to manage our user account. So that is why when you check our models, we will have only the user model. And then you will then create the routes, which is the URLs or the endpoints of the API that are going to be called in case you need the backend to do something. So at the moment, our backend is, as I repeat, mainly to manage users. So we have our sign up or the registration endpoint, and then the signing in endpoint. And then you also need to make sure you validate all these input fields. So we also have some validation code here. We wrote this validation code from scratch just to show you, like, to showcase but there is definitely a lot of models out there if you use your applications, in your backend applications. So there is models that do these validations automatically. So you don't need to worry about writing a lot of regex code and all this code to do your validation. So with all that said, now let's talk about how to connect to the smart contracts. And to start that topic, I'm going to start with explaining why are we even connecting to the smart contracts in the first place? Because actually, after yesterday's session, I received some questions from some of our followers that why are we hearing that there is going to be a backend of the application? Why don't you connect the front end, the React front end UIs directly to the smart contracts to fetch these balances and so on? So if you remember correctly, we have our UI, which was showcased by Femi yesterday, and he showed you this dashboard, which has the different balances for that you'll have in your, that someone might have in their account. So yes, UIs can directly contact, you can set up UIs to directly contact smart contracts and get all this data. But then when you look at our specific use case for this specific app, that is the CX app. So it is mainly the fact that we are using a custodian wallet. So a custodian wallet means that the wallet is not, like, every user that comes in doesn't actually log in with their wallet. So we just have a single custodian wallet, which is owned by C-Exchange itself. And this custodian wallet is what everyone goes through to access the smart contracts. So, and just in our past session that Femi just concluded, he mentioned that and emphasized that this is why we are having the private key, that everyone is going to, like all operations in the app are going to use that specific private key to be able to call the different factories or the different smart contract functions. So that answers why for this specific use case, it is not really wise to connect the UIs directly. So we have to have a backend which should manage the connection for everyone who logs in, because no one logs in with their wallet directly as it is for a lot of other platforms that don't do this specific thing. Okay, so now how you would start is you would start by installing Ether. So you install ethers.js, and you would do that by running a simple command. Let me zoom this. So you just run a simple command like npm I ethers. So it is already installed on my system, so it should just say already satisfied, but just run the command to show you how it would look. Okay, so yeah, so that is how you would install ethers.js. And then after that, then you would need to create you would need to add in your .env file. So the backend definitely has a .env, which is storing the different variables that you might use, the different environment variables. So in your .env, you make sure that you add the private key in the .env. Okay, so if you remember correctly, already we had a .env. Someone might be confused by this. Sorry to keep jumping back to the past session, but you already had a .env that had both the mnemonic and the private key. But these are for when you're running the hard package itself, not for running the backend API. So the backend API, you'll need to supply the private key again, or that is taking note that these two servers could actually run on different physical servers. So you can't say that I will still just pick it from the environment, since it was already set by running the other .env file or by sourcing it. So that is why you need to be sure of that. You still include that environment variable in your backend .env file. All right. So after that, then all you'll need to do is go to the specific functions or endpoints that you need to contact some functions from the smart contracts, or those endpoints that need to interact with the smart contracts, and then write your code in there. And that is a process I'm going to try to explain at a glance. We are not writing any code, so don't worry that it might get confusing. So now for our use case, the use case is that when someone comes and signs up, unlike a lot of other blockchain space apps, people usually sign in with their wallets. Here, no, you sign up as any other regular app. So you sign up with your email and also create passwords. But remember, the app is going to give you access to different crypto assets. It is going to give you a wallet that should be able to hold all these assets that you might own, or that should be able to receive the assets that you might want to transfer to it. So that means that on registration, the registration API should be able to call the function in the smart contracts. So I'll take you to the smart contract where the function that creates it is, so I'll go to contracts and then Exchange Factory. So you'll need to have your registration API able to call this function in the smart contract that Femi already created. So this new wallet function creates wallets or wallet addresses, something like that. So that means that you will need to call this function in your API endpoint. And then when you look into it, you'll realize that, let me zoom this just in case it's not very visible for some people. So you will notice that for this function to work, it requires bytes like it requires the UUID that is converted to bytes and then used. So now this user ID, where does it come from? I remember when Femi was presenting, he told you he usually just picks some user IDs from a certain site that generates them. So you can't do that in your actual app. So he does it for testing. So as he said, they would be probably the IDs from your DB, and definitely that is what we are using in our C-Exchange app. So when someone signs up, let me say someone called Ernest signs up. Now let me zoom this. Okay, I hope it is visible now. So when someone called Ernest signs up, let me be sure that the server is running. Yes, it's running. So you'll notice that, okay, we all know that whenever you create a new document in a MongoDB, MongoDB automatically assigns an ID to that document or to that row or object. So these IDs that MongoDB auto-generates for every document, those are the user IDs that you're going to take. So I'm using the word document. It definitely means user or the user row or the user object that we have created using our sign-up. So yeah, so using that, so we'll send that to that function, and that function should automatically create for us a wallet that will by default have 000 balances for all the assets that the app supports. And after that, that is all you need to interact with the smart contract for the start. Then when after you sign up, then probably you're logged in automatically if you decide to set it up that way in your own implementation of this app, or you might then redirect the user to the login page. So the login route doesn't interact with smart contracts in any way, because it is just the usual generic logging in. So it will just do some validation of the input data and then carry out a usual login and offer a bearer JWT token. We are using JWT for this specific app, but you can definitely use any preferred authentication scheme. So after that, now we understand that when someone logs in, they will definitely be redirected to this dashboard. And this is where we expect someone to be able to see all their balances for their different assets and maybe display their total balance in Fiat, USD. So how then would you achieve this? So that means you would only need an extra endpoint here that, so you need another route that is for fetching balances. And then when you create this route, it can just be like any regular GET endpoint. And when you have the endpoint that is supposed to return balances, so you return a JSON that has all these balances that you want to display in the interface. So how then does it get the balances? That is our concentration, as I said. So taking us back to the smart contracts. So as you can see, we have a file here called wallet implementation. And in this in this file, that is where we have two specific functions that are for getting the balance. Okay, so there is two. We have two. Let me explain why we have two. So we have an ERC20 token balance. So this will return to you when you give it like when you give it your token like your address, then it will return to you all these different ERC20 compatible token balances. So that means that will return your CUSD, CEURO, and Celo. So then for Celo, the Celo platform has also their native crypto asset, which is Celo. So then that is why we have this other Celo token balance function, which specifically returns the balance of this native Celo asset token. So then that would return to you that other balance. So these two functions are what you would need to call in that endpoint that returns the balances to the UI to be displayed in this manner. And with that, you would then have the most important connection to your smart contracts already done. And in the future, the app is still growing. So in the future, we are going to implement all these other parts of transferring, staking, and all those. So, but definitely they are not special at all. What I mean is that you would just connect all those different endpoints the same way we just connected the other two. You would just need to know, okay, where is my transfer function and which smart contract holds it. Then when you go to that, like here we have a withdraw function, you can look for a transfer. So you just need to know where the contract is that holds that function, get the exact name, then call that function in your API endpoint with the same setup that I just already explained and went through. And that would then bring out all the desired functionality of this application. All right, so that marks the end of how you would connect the backend to the smart contracts. Then this backend is also going to be connected directly to the front end as the normal way. So we are not making the front end interact with the smart contracts in any way, as I already emphasized. So that means the front end works natively as it always does connect with the other backends. Okay, so then that marks the end of my presentation, but I would like to also let everyone know. Yes.
Thank you guys for tuning in. Later this week will be the third installment of this workshop, and in that workshop we'll be bringing it all together, you know, building at the front end and connecting it to the back end, connecting the back end to the smart contracts, and then demoing the application for us to see what we've been building for the past 2 days. So thank you everyone for tuning in, and hope I see you again soon. Bye.